Yes, good afternoon to all of you. Is my voice is audible? Is I'm audible to all of you?
Yes, sir.
Okay, you can scan this QR code for the attendance. Yeah, all of you scan this QR code for the attendance. Okay, so let us start. Yeah, can you see my screen? All of you, it is visible to all of you. Is the screen is visible to all of you? Yes. Is my screen is visible to all of
Yes,
you?
sir. Yes, sir.
Okay, now this is lab
Yes,
number
sir.
10. Okay, today we will going to perform experiment number 10. And as you can see, this is your aim of the experiment. So this so we have today we will going to calculate the external and internal fragmentation. Okay, how we can find. So we have already covered this topic during the paging. Okay, or during the memory allocation in a operating system. So we have already seen when we are allocating memory, whether it is continuous allocation or uh, non-continuous allocation, there will be a fragmentation. Okay, or basically there are two types of fragmentation. One is your internal fragmentation, and second one is your external fragmentation. So we will today we will calculate this. Uh, how much basically the fragmentation means how much wastage of memory. Okay, while allocating the process, whenever we allocate a different process to the memory, so certain memory is always going to wastage. So the wastage of memory is basically called as fragmentation, and this wastage can be uh, studied in two different ways. One is your external fragmentation, and second one is your internal fragmentation. External fragmentation is something that is you have uh, enough memory, but that is not in continuous manner. Okay, suppose I require 200 KB, but this 200 KB is available, but it is not in continuous manner. Then we will call this wastage or this type of fragmentation as external fragmentation. And similarly, internal fragmentation, it is basically comes with fixed size partition. So when the partition size is fixed and the one process is allocated to it, what will happen? So it may be the process is maybe less than the allocated partition. So there will be certain wastage of memory, and that wastage of memory is called internal fragmentation. So this basically we will going to calculate these two types of fragmentation based on two different methods. One, the first method that we will going to use your called multi-programming variable tasks. Okay, it is nothing but your similar to your fixed variable size partition, how we will partition and how the memory is allocated. Okay, so first method that will be going to use it is your multi-programming variable task, and second method for calculating internal external fragmentation is your multi-programming fixed task or fixed partition. So this is your aim of the experiment, today's aim of the experiment. So all of you, please note down the aim of the experiment or the name of the experiment today we will going to perform. So all of you note down this name of the experiment. So these are the different now. First, we will discuss the first method, which is called your multi-programming variable task. By you have to we will going to calculate external and internal fragmentation while using multi-programming variable tasks. Okay, now these are the different steps we have to follow, or we can say algorithm for the this is the algorithm for how we will going to calculate the internal and external fragmentation using multi-programming variable tasks. Now, step number one is very simple. First of all, we will declare all the necessary variables. Okay, the variables such as storing the process, okay, or storing the process size. Similarly, uh, storing the attached memory, then number of partition block, how many blocks of partition. So whatever variables we require. So first of all, you have to declare all these necessary variables. Then second step is get the memory capacity and number of processes. So once we declare all necessary variables that we are going to in our program, next you have to declare what is the size of the memory. Okay, the memory basically here we are talking about the main. Okay, so what will be the size of my memory and how many process are going to store. Suppose I said this is suppose this is my size of the main memory. Suppose I said this is something about 4 MB. Then next thing what we have to what is that now how many process at a time how many process that I want to store in this memory. So you have to specify now this two will be the input given by the user. Okay, these two things is given input given by the user. Now once this input is given, as we go for the step number 3, what you have to do in step number 3, forget the memory required for the each process. Or suppose I say there is 4 process. Okay, 4 process are there and the size of the memory is 4 MB. Now what I have to do now, first of all I have to partition as we are using the variable tags. Okay, variable partition, the variable size partition use करेंगे. Now what I will do now, I will assign each process to the each block of this unit. Okay, now I will see whether now it's depend upon how the process will be allocated. Now it depend upon the size of the process and the size of the memory is available. Okay, if the size of the process is much larger than the available memory, then we can say that the process cannot be allocated. Fine. Now, while allocating, what you have to check now if the needed memory is available. Okay. Now, once you go to allocate, this is what I just explained. Now, while allocating, you have to need if the needed memory by the process is available. Okay, the particular process it will be allocated and the remaining memory will be available will be calculated. So what will happen if the size of the size of the process is less than the available memory? Okay, so the process size is less than its available memory, so we will allocate the process and rest of this memory will be calculated as an available memory which can be used for the next process. If not, that means if it is not available, then we can say the process cannot be allocated. That is, if not, it has to be tell no further memory is remaining and the process will not be allocated with the memory. Okay, if now if I say the process size is greater than, I'm saying the process size is greater than the available memory, so we can say the process cannot be allocated to this one. And whatever the memory is left, we can say that is your external fragmentation. Okay, then the external fragmentation process must be calculated. Means how much memory is wasted. It means how much memory is available. Okay, not used. That will be treated as an external fragmentation. In case of multi-program variable tasks. Now, in this case, as we are talking about a variable task, variable partition. Okay, so we know that in case of variable partition, there will be no internal fragmentation because whole total main memory I will take as a single block. So as the process are requesting, suppose the process one is requested, so I will get the process one. Now suppose process one is your 1 MB. Now rest 3 MB will be your available memory. Now suppose process two is allowed. Now I will allow process two. Okay. Now this will be your free memory. Now similarly process three. So whatever memory is left after allocating, that will be treated as your wastage memory. That can be, we can say, not wastage memory, this is fragmented memory, and this fragmented memory is called external fragmentation. So in case we have to remember, in case of multi-programming variable task environment, so whenever we're performing multi-programming variable task environment for memory allocation, there will be no internal fragmentation. Okay, there will be only an external fragmentation. Fine. So this is the aim of the experiment, how we are going to calculate. So these are the procedures that you have to follow. The simple 6 steps that we have to follow to calculate the fragmented memory of while encoding the process. Fine. So note down, all of you note down these steps, other different steps that we are going to follow. Yes, all of you note down these different steps. And so because you have to you have to write down the steps in your lab notebook. Okay, so do write down the steps, or you can say algorithms for implementing the this program. Okay, or we can say implementing this problem. So I will wait for a 5 minutes so that you can note down this algorithm. Yeah, is it copied? Yes.
No, sir.
Yes, sir.
You just wait for the 2 minutes.
Done, sir.
Okay. So uh, let us implement this program first. All of you open the editor. I will C++, basically type C or code block. So start this. So this is a C program. Okay, this is a C program for the implementation of multi-programming variable tasks for calculation of internal external variables. As we already note, these two the preprocessor we are using. Now, as a step number one, what I said, you have to declare all the variables that we are going to use. So here we are going to use three variables of M, M1 and M2. Okay, basically this variables are going to uh, we can say number of it will going to calculate uh, or we can say it will compare. Okay, whenever there is a process, basically we will have a process and free memory variable, so it will basically compare this variable comparison purpose. This variables will use for comparison purpose, and there is a p which will be used which is used to store the number of process. Then we will have a counter variable which will increment the number of process. Okay, this is basically used for the count purpose, and there is a I variable, okay, which will be used for your for loop, as we are going to implement number of process. Okay, so we require a for loop. For that we are using this I variable. Now step number, this is your step number one in your algorithm. It will compare. So first of all you declare all the variables that we are going to use. Now what is step number two? Now you have to enter your memory capacity and number of processes. Now this is a step number two. So what we have doing here, uh, we writing separate step. Okay, this is the step number two. This is step number two. Okay, now what is happening here? Now we are asking the what is the memory capacity, and this memory capacity is basically stored in the variable M. As I said, this is 4 MB. Now store SM, and next we are asking what is the number of process. Okay, how many process that we will going to allocate to the memory. Okay, so this process is going to store in this particular store the number of process, and M is your size of the memory. Then what we have to do now, step number 3, as you can see here, what is step number 3? Now step number 3, you have to allocate. Okay, yes or no? Now once you have find, now you can see here step number 3. Now step number 3 is get the required for the each process. So next, what we have to do now, we have to get the each process. Suppose I said there is a 4 processes there. Now I will get the memory required for the each of these process. For that I will use the for loop here. Okay, this for loop what will do, it will simply simply find the number of uh, what the memory required by the each process. Okay, and this we will going to store in M1. Okay, now this will be going to store in M1. So once this M1 is, suppose the process, suppose as a process 1. Okay, while first memory is allocated to process 1, now I will check whether this required process memory, now I have to check whether this required memory is less than M. So good, when we are storing the memory in M1, I will check whether this is less than M. Only possible, no. If it is the size of the process is less than the value memory, then only we can have. Otherwise, it will not possible. Now, if it is less than M, now if it is true, now I am checking this condition. Okay, for allocating. If this is true, this particular condition is true, then I'm checking count equal to M. Now what by count equal to M? Initially we will take count that equal to M plus memory size. Okay. This is initially equal to 1, so it will be M. Now if it is 2, then simply there is no further memory remaining. If it is 2, that means there is the memory is full. We cannot allocate this one. If it is false, okay, if it is false, so we can say we can allocate and the size of the can be allocated. That M2 will, what M2 will give here. Now suppose this is 1 MB. Now suppose process 1 is 1 MB. So what the M2 will represent? Now M2 will represent what amount of memory is for the multiple. That is M2. यहाँ पे क्या करते हैं हम लोग? M2 equal to M2 is equal to what we are writing? M minus M1. This will be giving you how much memory is available for the next process. Okay. So यहाँ पे हम लोग करें now next time this for loop will get continue. So what I have to do next, available memory is equal to M2. It is the reason we are assigning M2 is free available memory. For next iteration, what will happen? M2 will be, if now if this condition is false, okay, now this is for this, if now this else for this one, if this condition is false, that means the memory is larger than the required process memory, larger than the available memory. So what does that mean? That means that we cannot, or we will not able to locate. Okay, we will not able to locate this memory. So that we simply print a message that memory is not allocated to the process, particular process. And how to calculate the internal fragmentation? There's external fragmentation, because there will be no internal fragmentation, there will be only external fragmentation. So whatever memory is left, okay, after assigning all this process, okay, P1, P2, P3, how many processes are there? Whatever the memory will be left, that will be your fragmented memory, okay, and that particular fragmented memory is called your external fragmentation. That is the reason I've given M2, because once the last process is allocated, okay, and for the last process allocated, and when you calculate this M2 for the last process, okay, once the last process, suppose P4 is allocated, once P4 is allocated, so if I calculate this M2, okay, so what will be M2 will give? Now it will give the free available memory. Okay, what are the free available memories available? And this available memory is called fragmented memory, or in this case we will call this is your external fragmented memory. So let us see how, let me run this, run the program, and then we will see the output, then it will be much clearer to you. So first of all, compile or save this file. This file is fragmentation. takes some time. It is already compiled. If there is a no message, okay, then you can see this is the program consist of no error. Then you will run this program, execute run this program. Okay, now you can see here. So what is asking here? Enter the memory capacity. Now to enter the what is the size of the memory. Suppose I say size of the memory is 1. Okay, that means 1 KB. Yes. Okay. Fine. So now it is asking enter the number of processes. Now how many processes we require? Now how many processes we require to allocate to this memory? Okay. Now suppose I say the suppose I want 4 processes. P1, P2, P3, and P4. 4 processes. I want to allocate. Now this is the 1, 0 to 4 memory is available. Now I'm not partitioning, okay, because it is as a variable size. I will consider whole this memory as a available or single block. And there is a 4 process I said P1, P2, P3, and P4. Now let me size the process also. Let me size the process also. Suppose the size is suppose this 100 KB. Fine. Now let me give the number of process here. 4. Fine. Now it is asking enter the uh, enter memory required for the process 1. So what are we are given? So I have already given, you can see here what is given. The memory required for the process 1 is 100. Right. You can see once I given what is happening here. Now you can see once the process 1 P1 is arrived here. Okay, I've given size 100. Now 100 block is allocated. Now P1 is allocated to here. Size allocated to this one. This is 100. Okay, you can see here now the memory allocated to process P1 is this much block is available. Now 100 is allocated. Now what is remaining? Remaining is you can see now 1024 से आपका 100 आपका minus हो गया, which is your 924. This is my M2. Okay, this is my M2 which we are calculating. This is the free available memory for the next process. Fine. Here this point how we are getting. Now this is first of all this is 1024 is available. Once the process P1 is arrived to the size 100, now we first of all we check okay whether P1 size of the P1 which is nothing but M1 is less than M. M is your actual memory. If it is so, then we will allocate. Once we allocate, now we calculate the what is the free available. The free available is 924. Now it will asking the enter the size of second process. What is size of second process? It is 150. So now what will happen? Now, as per the concept, this 150, first of all, check. Now, first of all, check this P2 is less than M. Now, what is the value of M here? Now, the new value of, in previous case, the value of M is 1024. But in this case, what is the new value of M? The new value of M will be 924. Fine. Now tell me whether P2 is, yes, this is true. P2, what I will do? Now, again, I will allocate this one. P2 को हम लोग allocate कर देंगे. Yes. How much memory is allocated? 150. Rest will be free available. Now what is new M2? New M2 will be your 150 will be subtracted from this. This will be 4. Now 12, 5, 4, 6, 7, 8, 7, 74. Free available. Let us see whether we take this answer or not. Now 150. See here what is the allocated. The memory required is P2 is 150. What is available? 921. The condition is true. Now we have allocated. Now what is the free available memory? 774. Free available memory is 774. Now what is this memory? 774. Now what happened? Now next P3 will be requested. Now I will check again whether P3 is less than M. Now what is the new value of M here? The new value of M here 774 is valuable. So as you know 300 is less than 774. So what will be this P3? P3 will be 100. What will be my new available memory? It will be 774 minus 150, which will be 4, 2, 6, 8. Now this will be my new memory that is really allocated. What I will do, let us check whether it's correct or not. I will give, sorry, it is 300, no? So it is 300, it will be 474. Okay, 474. It's 474. Okay, not 170. 300, 470. Now again, last time again check, I will check. There is a P4. Now whether P4 is less than M. Now what is the new value of M is here? It's 474. Fine. So the condition of 400 is less than 474. It is true. Yes. Now what is the free available? Now 474 minus 400. It is what? 74. 74 memories. Finally, when you located on this process, P4 is located. Okay, which is your 400. Now how much memory is left? How much memory is left? It is left to 72. And this is called a fragmentative memory. This is called a fragmentative memory. In this case, it is called, this is your external fragmentation. Fine. So let me check whether we are getting the correct answer or not. 400. Let's see. This is memory located 400. And what is the remaining memory is available? What are the memories available? The remaining memory is 474. Fine, 474. And this remaining number is called external fragmentation for this process. When this process, whole process is allocated, this is your external fragmented. Is it clear to all of you how we are calculated? Now this is for what? Multi-programming variable task. Okay, multi-programming variable task or variable partition. Multi-programming variable partition. Okay, how we are following the process, how we are calculating this external fragmentation. How much memory is fragmented memory is available? You can see fragmented memory available after locating this process is 74 KB. Is it clear? I hope it is clear to all of you. Yes.
Yes, sir.
Fine. Note down if you want this. Note down this example. At least the question part what we have taken. Total size of the memory is 1024 and process are 4 process. This is my process and each type the first iteration. What is the value from 2? It is 924, which is your value of M for the next iteration. It means next iteration के लिए आपका M का. Now second iteration के लिए M2 का value क्या हो गया आपका? It is 774, which is value of M for the next iteration. That is third iteration. Now this third iteration M2 का value क्या हो गया? 474 and fourth iteration M2 का value क्या था? 7. Once the process is completed, this is my fragmented memory. This is my final external fragmented. Okay, note down. We have 2 minutes. So note down and do enjoy the same link where I am going to share the code with you. Then you have to implement this. Once the link will be disconnected,